In this example, we're going to use a grid to find the probability of an event occurring. So here's our question. Using a two-dimensional grid to illustrate the sample space for tossing a coin and rolling a die simultaneously, from the grid, we want to determine the probability of tossing a head, getting a tail and a 5, and getting a tail or a 5. So I imagine this is supposed to say rolling a die, but it's kind of funny, rolling a die. So let's start off by making this two-dimensional grid. So we're going to do what I did previously, and let's make two axes to this grid, something like this. We are comparing a coin, so that's going to be a pretty straightforward axis. That's going to be just a head and a tail. And that'll have two lines coming out of this. Let's do a different color. So we could have a tail, or we could have a head. And we're going to compare that with rolling a die. So there's 6 possibilities for the die. So we'll have a 1, a 2, a 3, a 4, a 5, and a 6. And then similarly, let's make some lines come out of each of these possibilities. And remember, each of the nodes or intersections of these tails or these lines, they represent possible outcomes. So I could get a 5 and a head or a 5 and a tail. That's those intersections. A 6 and a head, a 6 and a tail. That's what all of these things represent. So if I can use this grid to come up with all of these different probabilities. So basically, what I'll do here is I'm going to grab a let's use purple for letter A. For example A. I want to find the probability of tossing a head. Well, first thing that I should do actually is probably count all of the nodes, all of the possible outcomes, all the intersections. And there's 1, 2, 3, 4, 5, 6, and another 6. So far I should just keep in mind that there are 12 possible outcomes. So I should use 12 as the denominator for all of these probabilities that I'm coming up with. So the probability for tossing a head, that's going to be illustrated by all of these nodes. Each of these has a tossing of a head as an outcome. That's 6 favorable results out of 12. So that's going to be a chance of 1 out of 2. All right, that one was pretty easy. Let's do the next one in blue. And I want to find the probability of getting a tail and a 5. So I want to look for getting a tail, flipping a tail. That's all of these nodes here. But I want to also get a 5. So it's not an either or, this is an and. That means that both of these things have to happen. So I'm looking for a tail and a 5. The only time that happens is right here. So this is going to be a probability of 1 out of 12. All right, and then for the last one here, let's go green. And I want to find the probability of getting a tail or a 5. Or is pretty important here, because the or means that as long as any or both of these outcomes occur, then this is considered success. So anytime I get a tail, that is a success. Or if I get a 5, that is a success. So basically, all of these outcomes represent success for getting a tail or rolling a 5. So how many of these nodes did I just circle? So 1, 2, 3, 4, 5, 6, 7. So this is going to be represented as 7 out of 12. And there are my chances, my probabilities. So the grids can kind of help us to see what the successes are, and we can count that sample space just like we did before. Why don't you try this example? Very similar. This time we're talking about a spinner, and we're going to spin the spinner, and when it lands, there will be like one side or one piece that is up. So this is considered rolling a 2, just so you can understand what I mean by spinner. Spinning a spinner. Or twirling a spinner. So why don't you pause the video, give these 3 sections a shot, make a grid to help you out, and check out the answer when you're done. So here is my grid of both of the spinners. You'll notice that here are the answers, and they've been identified as what sort of marking you use to refer to each one of these things. Hopefully it went okay.